Alright guys, so today we're gonna do a quick review with 8 questions for the Unit 3 AP Computer Science Principles test. So this is based on projectstem's curriculum, and for Unit 3 modules, it is on binary and lists. So let's get started. So remember that state space refers to the space of all potential possibilities. Which dichotomous questions below will successfully narrow down the entire state space of flipping a coin and rolling a normal six-sided die to one or fewer possible outcomes regardless of the answer given. So it's basically asking us which set of questions will allow us to get down to one possibility of rolling a six-sided dice and flipping a coin. So to do this, we can give ourselves an example. I'm going to say I rolled heads, and for the dice, I rolled a number 5. So we can start with this first one right here. It asks, question number 1, it asks, did the coin land on tails? No. So right away with that question, we can tell it landed on heads because you didn't land on tails because the coin only has 2 sides. And question number 2, is the value on the dice less than 3? My 5 is not less than 3, so I will say no. So that means we are now able to know that it's either 3, 4, 5, or 6, because asking if it's less than 3, which also means that it still can be 3. But those are the possibilities when I answer no. If I answer yes, then it's either 2 or 1. Number 3, is the value on the dice even? No, it's not. And because I answered no before that, so it's either 3 or 5 now. And then number 4, is the value on the die 4, 5, or 6? And so I will say yes, it is number 5. It got to number 5. So this possibility will work, but you have to keep in mind that if we are trying to do another number, it might not work. So we can try another number. But in this case, you would think this is the correct answer. But of course, you have to try the other answer choices. And if one of them is the same, then you know that you messed up on one of them. So you would try another number for another one. Anyways, this one is wrong because, look, it asks, is the value on the dice even? But then the next question it asks, is the value on the dice 4, 5, or 6? 4 and 6 are both even, so why would they ask like that? So if we're changing it here, our number isn't 5, but our number is 6 instead. So number 2 I would answer, number 3, we would change our answer to yes. So just erase that. So that means we know that it's 4 or 6, but then it's asking is a value 4, 5, or 6. If you say yes, we'll never know if the value is 4 or 6, so that this answer choice is wrong. And then we can basically do the same thing with the next answer choices, so you guys can do that on your own. And so if you guys did that, the answer should be this one right here. So we can go ahead and do an example that we landed on heads and our number was 3. So these kinds of questions, the set of questions that should be correct, should work on any number or any heads or tails that we got. So question number 1, yes, our coin did land on heads. Question number 2, yes, our value of the dice is odd. Question number 3, is the value on the dice more than 3? No, it is not. Does the value of the dice equal 1, 2, 5, or 6? No. So that means we know that it's 3 because it does not equal 1 or 2 right there. So then that means we know that it's 3 because our number was less than 4, or we know that it was not greater than 3. So then it's 1, 2, or 3 from question 3. So here, 1, 2, 3, we know that from question 3 was 1, 2, 3. But then question 4 asked, is it 1, 2, 5, or 6? The answer was no, so then we know that it's 3. And then you can do an example for another number for this answer choice, and it would still be correct. Unlike number 1, where it didn't work for 4 or 6. And this one right here would be wrong because this question right there, that would be very useless. There's no point of asking that question and it wouldn't work because multiplying by 4 still keeps it even, any number even, and it already asks is value on the dice even, and yeah. But multiplying any number by 4 is going to keep even because 4 is an even number. And so if a multiple of 4, then it's even. Because you're adding 4 each time. You keep increasing by 4. It would still be even. So that's how you solve that question. This next question is fairly simple. So I will give you guys a summary of this. This is just basically asking just some background. You guys can read it, but then it's asking what is the return by a call to taxman, parentheses, food, and $1. So it tells us right here what would represent inside the parentheses. And so food would equal category, and 1 would equal the cost. So that means that this is basically like what we get to choose as part of the procedure, which is what a procedure is. If you want to change one thing, you don't have to change it the whole entire time. You just need to change one simple thing and it will still work. So right there. So we know that the food is our category. So if we look out of these 3 if statements, this right here says food, category, food. And so $1 is the cost. So right here it would be $1. So $1 or 1 times 0.06 would keep it the same. So it's 0.06, and that would be new is 0.06, and we know that old is 0. So first of all, we can cancel out these. We won't be using these because it says if the category is closed or if the category is other, which it is not because the category is food. So we only execute that. So now after that, and then we would go to return, and return is new subtracted by old. So that means it's 0.06 subtracted by 0 because old is 0, which would equal 0.06 or 0.06. So that would be our answer. This would be our answer. So this question right here is a little bit on the harder side. This will require a little more thinking than the previous one that we just did. So consider the following procedure, and which of the following best describes the behavior of the find procedure. So what will kind of be displayed of doing this procedure? So once again, we have this, which is like kind of like what we can put inside of it ourselves. So it's a list. Okay, but here it's a list. So we can give ourselves a list example here. And we can see that it says, so here we can see also that it says for each item in lists, the amount of times it will repeat is the amount of items it is in the list. So let's say the list has 5 items, it will repeat 5 times. So it says for each item in list, it will so. Let's do this right here. We're gonna put 3 items in the list. So number 1 in the list is Target. Number 2 is math. I'm just giving random things. And number 3 is Target. But I put Target because Target is part of the problem. It says if item is Target, then yeah. And item basically means like the number in Target, because we're repeating each item. So if we're on our first repeat, then that means item equals 1, so item number 1 of the list. And so it's saying if item number 1 of the list equals Target, then it will display 1. And as you can see right here, before we started this repeat, I equals 1, so it will display 1. Because this is true, the first repeat is true because number 1 in this list right here is Target, so then it would display 1 so far, 1, and that means that item number 1 did have the word Target. And so now let's repeat it for number 2. So that means we're on item number 2. So item number 2 equals to Target, but that is false. Item number 2 does not equal to Target. So that means that the code will not execute for that time, but it will still add 1 to I. So I is 2, but we're not going to display that. but the I did increase in value, so that if it does want to display item number 3, it will be the number 3 instead of 2, if you get what I'm saying. And so the third time it repeats, item number 3 does equal target, so it is true there. So it will display 3. And so as you can see, it only displays the numbers that actually have the word target in them. So read the answer choices and see which one would be the best. So this one right here says that it would be this one right here says displays the position of the first occurrence of target in a list. No, because it also displayed number 3, which also had target. The second one says display each item in list that is equal to target. Although that is true, in the front it says here display each item. We're not displaying item. We're displaying the position number of the target. So the first target was in position 1, and the second target was in position 3. We're not displaying each item, so that's why that one's incorrect. Display the positions of all occurrences of targets. Yes, this one's correct, so we would choose that one. And the last one says display the position of the last occurrence of target. No, because we did also do the first occurrence. So it is all occurrences, so number 3 would be the correct answer. Okay, so here's our next question. This one is pretty easy. This one is just math we want to do. So, and make sure that you are doing your math correctly too, because I actually did get this question wrong the first time because I did not pay attention to what I was doing. So let's go. So what is the value of z at the end of this procedure if x was 20 and y was 2 when the procedure was called? So right now we have x is equal to 20 and y is equal to 2. So let's start the procedure called change xy. So if x is greater than 10 or y is equal to 5, this or right here means that only one of these has to be true to execute this code. So, is y greater than 20? Yes, this is true. Is y equal to 5? No, this isn't true. But it will still execute because this first one was true. So, first one would be 2 times 20, which equals to 40. So now x is equal to 40. And so we want to do this. So y will now equal to 40 divided by 4, which is 10. And so y is equal to 10, and then the x right there is 40 plus 2 is 42, so x now equals 42. So this is what we have now going into this if statement. So if x equals 10 or y is greater than 20, which none of those are true, so that means we're going to be doing this else statement, not this. So else y will turn into x. So y is equal to 42 now. And so 42 plus 42 is equal to 84. So that's our answer. Ow. So this question shows us a Scratch program here. So assuming that the list favorite songs is initially empty and the user responds to each request for input, how many items will the list favorite song contain after the program is run? So this program adds songs to a list called favorite songs, and it wants us to know how many items will be in the list at the end of this code. So let's see, set index to 0. So we see right here that that it says it will repeat the length of favorite songs. It will repeat until the length of favorite songs will equal 10. So that means that this entire thing will keep running until it equals 10. So, and here it says it keeps adding answers. It adds one item to the favorite song each time. So that means the answer would be 10 because it stops repeating once it reaches 10. So this next question is one of the harder ones. So let's read this. A gaming software company gave their new customers a survey, asking them to rate various aspects of a new product on a scale of 1 to 5. The integer values of their answers were stored in a list feedback. Which code segments would assign the mean average value of the items on the list to the variable average? So select 2 answers. So it's basically asking us which 2 of these 4 procedures or codes will work to find the average of all the feedbacks that they were given. So again, like the other question, the target question in the target list question, we can give ourselves our own list, and then we can let's put 4 feedbacks. So 1, 2, 3, 4, and it's a rate from 1 to 5. So let's say number 1 chose 4 out of 5 stars, number 2 chose 2 out of 5 stars, number 3 chose 5, and number 4 chose 4 again. And the code is supposed to find the average of these 4 ratings. So let's check number 1. So at the beginning of the code, it would set sum to 0. And then it will repeat, for each item in feedback. So it will repeat 4 times in feedback because, for our example, we have 4 items in there. And so it says item, so we know what item is here. Item would be, it would add the number that we have on item number 1, since our first time repeating will be item number 1. And so we know that sum is 0, so 0 plus 4, and then it would make it 4, and it will repeat 4 times. So then the next time they do it, the sum is 4 plus whatever the next feedback is. So that's 2, for example. So that does work. It keeps adding up into the total, which is 15, and then 15 divided by the whole length of feedback, which is 4, that is how you find the average of something. So that means this one is one of the answers. So let's check the next one. The next one says for each item in feedback. So yep, but it sets the sum inside the loop or the repeating code, which is wrong because every time we would repeat it, we set sum back to 0. So eventually, once we repeat this 4 times, sum would equal 4, because 4 is the last number, because we're setting sum to 0 each time, and the last repeating would be 0 plus the 4th item, the last item, so 4. So sum would equal 4. So that's wrong. This is wrong. So number 2 says it sets sums to 0 before. That's correct. We know that from our last 2 answers, or our last 2 answer choices. And then it sets item to 1, so it uses something extra. It sets item to 1 because it instead of saying for each item in feedback, it says repeat length feedback times, because it doesn't say for each item. It doesn't say for each item in feedback. So that's why we need to set item to something. So repeat length feedback times. The length of feedback is 4. The length of this is 4, so it would repeat 4 times. Messy handwriting, sorry guys. So 4 times sum, no, that's 0 plus feedback item. So right now item is set to 1, so item number 1 of feedback is basically what that means. So that would be 4, so 0 plus 4, and that's 4. And every time it would also add item, it would add 1 plus to item. So right now it's 1 plus 1, so item would equal 2. So the next time we repeat, item will equal 2, and it will keep adding on, so plus 1, and then it will equal 3 next. So let's erase that stuff. Kind of messy. Sorry guys. And so we know from before sum is equal to 4, since 0 plus 4 before that. And because we added 1 to item, remember? So the item here would be 2 now. So item number 2 of feedback, which is 2. So plus 2 would equal 6. And it would keep doing that until we do eventually get the sum with this one. So this one is probably correct. 15 divided by length of feedback. Yep, this one is correct. So this one is our answer choice. And then lastly, this one. It says sum is set to 0 before the repeating code, right? Here it says repeat length of feedback, and then it says sum plus item. What is item? It doesn't tell us what item is on this one. Item is unknown for this one. Here it does say repeat length of feedback times, but we do know what item is. It tells us before. And then these two right here, it says for each item in feedback, so it does tell us what item is. So this one would be wrong because we don't know what item is. So this is wrong. And so that's how you do this question. And this is our last practice question. So this one's basically a math one. So subtract one current value of y and store the answer as the new value of y, set the value. So this is basically the algorithm. And so it's asking which of the following best describes the behavior of the algorithm based on the starting values of x and y. So we can give ourselves x as any number and then y as any number. And we want to know if this code will work on certain numbers or it won't work. So pause the video and try this question out on your own. Okay, so the answer would be C. There are many possible starting values of x and y which will cause the algorithm to eventually terminate, which also means work, and many possible starting values of x and y which will cause the algorithm to run infinitely, or like it will just keep running. It will never get to x equals 10. It will never stop. It will just keep repeating because x will never equal to 10. And that's the correct answer because we're subtracting 1 from y and we're always setting the current value of x, or the current value of y, to x. So that means that if the starting number of y is less than 10, then x will never get to be 10 because we're always subtracting 1 from y. So if it's 9, we keep subtracting. We subtract 1 from the current value. We do add 1 here, but once we add 1 plus 9, we subtract 1, so it actually gets to 8. And then we plus 1 there, so it goes back to 9. That's kind of what this is. Kind of like if we have 11, and then it goes to 10, but then it goes back to 11 there. That would work. But if it is, as you can see, if the number is less than 10 will work, but if it's less than 10, we will never get to x equals 10. So that's why there are multiple possible ways to get it to terminate, but many possible ways to get it to keep running. So that's why C is the answer. So thank you for watching, and that is a review on Unit 3, and hopefully you guys do well on your test.